Friends, and in this video we are going to discuss about a very popular mathematical concept called as relation and functions. Since this is the video series for the calculus particularly, so that's why we have to start from the relation and functions. Now before explaining you the functions, I would like to know that what are the relations and how they are formed. So for that, first we have to understand the Cartesian product. What is Cartesian product? This is like, suppose if you have a set A and it has the elements like 1 2 3, then you have another set with the elements A B C. So you have a set A which has the 3 elements in it, and then there is another set called the B and which has 3 elements A B C in it. Now we'll find the Cartesian product. And what is that? Cartesian product is called as A cross B, or we can also have B cross A. So A cross B means, what is A cross B? So you can just take, if you like the grid structure, then A you can plot it as here 1 2 3, and this is your A, and slice B. B I would like to write here. So this is A B C. So when I am trying to find out A cross B, then I write the elements of A first and the B second. So that is called as 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, and 3C. Now the Cartesian product from set A to B is defined as A cross B is ordered pair A comma B such that A belongs to capital A and B belongs to capital B. So if I would like to write this set notation from here, then in the roster form this A cross B can be written as 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, and 3C. If you want to express this whole thing in the form of mapping, then it can go like, this is my set A, this is my set B. A have the elements 1 2 3, and B have elements A B C. So now you see that we got the relation like the 1A, it means like 1 to A, 2 to A, 3 to A. Then we have 1 to B, 2 to B, like this one is 2A, 2B, and this is 2C. Then you can have 3A, 3B, and 3C. Now the relation is, this relation is just a subset of this set. So it's written that R is subset of the Cartesian product A cross B. So R is just a part of the rectangular Cartesian product or the Cartesian product A cross B. Now for example, I can take, because if you just take A cross B as a set and it has the number of elements in the set A, so we can say that the number of elements in set A is 3, number of elements in set B is called as 3. So this is 3. So the number of elements from set Cartesian product A cross B will be 12. And if you want to make a power subset, that is the collection of all possible subsets coming from this set, then its number will be 2 to the power 12. That is a huge number, and one just part of this subset, like you can take any 4 elements. For example, if I say that my relation R, this R from A to B definitely is 1A, 1C, 2A, 3B, like that. This is just, I have taken only 4 elements from so many elements, and that is my relation, and that relation is from A to B. And then you see that we have the 1A, 1C, 2A and 3C. Now you see that the what is domain? Domain of the relation. Domain means the set of all the first elements of this set. That is 1, 2, 3. Do you see this bottom? This one? Okay. So here you can delete it also. So now range. What is range? And codomain. Codomain is the set of all the elements of this set, like the A, B, C. So here we can write codomain. That is A, B, C. And what will be the range? Range will be all those values which are connected, all the second elements which are connected in the relation. So A is connected, C is connected and B is connected. So our range is also A, comma B, comma C. Now let me remove this one and then I come back to you, and then I'll draw again the relations mapping. काटो मत, pause कर दो. So this is the R. Now I want to represent this in the form of mapping. So this is my set A. This is my set B. Now you see this is 1, 2, 3. R have, A have 1, 2, 3. 1, 2, 3. And these 3 values from the set A, these 1, 2, 3 are called as domain. So the domain you see 1, 2, 3. This 1, 2, 3 are the domains. And the B is this element, this set, which has the elements like A, B, C. So here I have taken A, B, C. Now you see in our set, 1 is connected to A, 1 is connected to C, 2 is connected to A, and then 3 is connected to B. This is the mapping between A and B for this particular relationship. So now you see the domain. What is domain? The set of all the elements of the set A are called as domains, which are the set of all the elements which form the first element of the ordered pair AB are called as domain. And these two elements, these A, B, C, are called as codomain. Suppose I do not have anything. Suppose there is one more element D here. Then suppose D is here, but this is not connected. This is not connected to this mapping. D is just isolated one. Then your codomain will become A, B, C, D. But the range is only those connected points. That is just A, B, C. This is idea of the function. Now if I want to plot it on the line diagram or on this diagram, suppose if I say that my A is domain values, this is 1, 2 and 3, and suppose A is here, B is here, C is here. So this is, I use as a scattered point kind of diagram. That is, now see 1A, so at 1 you have a point A, and then you have 1C, so this is one more point. Now 2 is related to A, so at the 2 also you have A, and 3 is connected to B, so 3, this is the point B. So now these 4 points are there. Now the question is that whether this relation is a function or not, that we'll discuss just little after. Let me clean the screen because I have to get rid of this one, because we have to understand what is the function, because function is again a subset of relation, and all relation can be a function. All the functions are the relations, but all the relations are the not functions. So the functions are the special kind of relations. Now there must be some restrictions definitely because it's mathematics. So now just wait and I'm coming back. Yeah, so the function. Function, what is function? Function definition goes like, a function is a relation. A function is a relation from A to B such that each point in set A has one and only one image in set B. Means one point of set A. Now here in this terminology, this A is the image of 1 because A is related to 1. So A is image of 1, B is image of 3 and C is image of this. So by definition you see, each point in A has only one image. But what do you see? Now see, 1 is related to A and 1 is related to C. Means 1 has two images, A and B, C. Or this one is called the pre-image of A. B is pre-image, sorry. A is called, just try to understand terminologies. A is called image of 1, B is called image of 3, C is image of 1, and here A is image of 2 also. So A has this 1, has two images, A and C. So that's why by this definition, because it says that each point in A, like the 1, 2 and 3, must have only one image. Now you see the relation. 2 is connected to A, it means the A is only image of 2. B is similarly only image of 3. But A and C both are images of A. It means this relation, what we have written here, that is now here plotted. Now you see this is what it was. Our relation R was 1A and 1C, 2A and then 3B. So now this is not a function because A and C, one has two images, A and C. So by this definition, this relation is not a function. Now can I make it a function? Yes. If I just remove this point, any one of these two, now then it will become a function. Now you also know that there is one idea that when you are given a function, then how can you check? Because that function, every function can be graphically plotted, and there is a criteria that if a function fails in the vertical line test, then that is not a function. That we'll discuss later. But right now, suppose if I remove this C, so I have only, means I have removed the relation 1C. So this relation I simply remove, and then you find this becomes a function. So I don't need this 1C. Now in this condition, now you see that we have 1A, 2A, that is fine. 1A is fine, 2A is fine. A is the image of 1, A is the image of 2. This is fine. That is not a problem because each point A should have only one image. So 1 has image A, 2 has one image, and the 3 also have the one image. There is no problem with that. So this is a function. Now if I map it again, then what I get? This is my A, this is my B, and I represent it from FA to B. This is 1, 2, 3. So 1 is related to A, 2 is related to A, and then 3 is related to B. We have two more elements, D and C, but I am not relating them. So now let's try to understand what is the domain. Domain is the set of the first element, that is 1, 2, 3. Codomain, that is set of all these elements, that is A, B, C, D. And range is the collection of only those values which are connected, or you can say that here, that is A and B. This is idea of the function. Now if this is function, A is 1 is related to A, 1 is related to A, 2 is related to B, and 3 is related to this. So now you see that there is called if it is graphically represented, and if you draw a vertical line. So if I draw a vertical line, then every point is just associated once. It means this is the idea of the function. Thank you very much. Now keep on watching and subscribe to our channel.